This is Amee Evans Godwin, and I'm with my colleague Cynthia. We're having our first foray into Sococo, so really happy that it's working out for us technically. Great to see you, and we will be telling you about an initial project and some exciting work we've been doing with that. So who is ISKME? What is ISKME? We're a small nonprofit. We're based in Northern California, and we have been working for the last 15 plus years in the area of knowledge sharing and education. And this is a combination of information and library science, social science. We're not math modelers, so don't ask us to do any differential equation solving today. But we're here really to talk about learning and open education and where we can really make a difference around making resources that are open and available more participatory and easier to use for all learners. So our work is around making evidence-based tools through applied research. It could be frameworks and other programs that really support educators in particular to make their materials more flexible and more easy to find. We've been developing the public digital library, OER Commons, for the last 15 years, which is, in addition to a library environment, it's a collaboration environment that has authoring and curation tools for those that are looking to make their learning materials easier to find. The work we've been doing in this project has been going on for a few years. It's built on work we've been doing with CAST, which is a national organization based in DC, and they run the National Center on Accessible Educational Materials, or the AIM Center for short. And in this project, we wanted to expand and go deeper for that work to build tools and processes to help STEM faculty in particular to determine if open materials that they're looking for, creating, or evaluating meet accessibility requirements for their classrooms and for their campuses. The work has been supported as part of a mini grant program through Bates College in Maine that received a grant from the Hewlett Foundation. And we've been able to work with partners in the SCORE network, a group of STEM education organizations, and in the CUBES network. So a lot of this work is really rooted in collaboration. For those that may not be completely versed in OER, I'll give you an intro or a quick review. OER can be materials that we're talking about in the digital space. Could be any type of teaching and learning materials. It could be a whole course, or it could be ancillary materials like videos and assignments. It could be tools and software, simulations, data sets, materials that you find online that have in particular been given an open license or are already in the public domain so that anyone can use them, reuse them, and in many cases adapt and change them in ways that fit and are customized to a particular learning environment. But today we're going to go beyond OER as a legal or an economic model, because the driver of this originally had been around cost, that materials really should be available and not be a barrier for students or anyone else to be able to learn. And beyond that is where materials become flexible and really can impact teaching and learning. We began this work to examine accessibility by defining accessible, being rooted in the Department of Ed's Office of Civil Rights, OCR, definition that is really about providing equivalent experiences for anyone with a disability. And we are expanding on this definition for this project to really go beyond, to encompass, but go beyond this notion rooted by the foundation in open education, which we'll talk about a little further. Open education provided us a way to broaden the definition of accessibility to include some of the principles that are contained in UDL, or Universal Design for Learning. This framework is really emphasizing the notion of learner variability. So not only a concentration on disability of learners, but that learners vary across a wide range, have their own preferences for learning, and can be part of the design process for instructors and curriculum creators to build with the notion of including all learners for as much as possible, not in the sense of accommodating disability, but really from the start, thinking about multiple options for engagement. And this framework can be found at the CAS.org website if you want to dig deeper into that. So I'll pass it now to Cynthia to talk about the project and the outcomes of the creation of the guidebook.
Great.
I'll stop sharing. Yeah, and we'll switch.
Okay. Great. Okay, can you see my screen, Amy? Yes,
Yes.
Great. So we stepped into this project with the understanding from our partners in the higher ed space that STEM faculty lacked the tools and frameworks needed to really evaluate OER for accessibility. So the rationale behind the work is that we wanted to provide tools and STEM resources to really support STEM faculty in kind of jumping in and being able to assess the OER that they find online and to create their own OER. Because, as Amy mentioned, OER can be quickly accessed and legally adapted. It provides a great sort of starting point for making resources accessible for the classroom. So our rationale then is that we really wanted to support faculty in evaluating OER and to really be able to start to develop STEM course materials that support access and use by their learners, and to expand the materials they're able to offer beyond the traditional textbook to address a wide variability in learning. And in sort of framing that rationale in a set of questions, we wanted to help STEM faculty answer questions like, how do I know if the open resource meets the accessibility needs of my learners? What must be changed to make it more accessible? And then how do I remediate that resource once I determine its gaps? So I've got an example here of an open educational resource on differential equations that can be found in many OER repositories, including ISKME OER Commons. And when I looked at the metadata on that resource, it had a few tags that were mostly about the content of the resource, but none of the metadata told me whether this resource was accessible or if it had been evaluated to meet accessibility requirements, which is again pointing to the need for this kind of work. So in order to really move into this project, we first wanted to convene an advisory council of STEM experts. So we worked really very closely with Sean Fox, who is with the Science Education Resource Center at Carleton College, as well as four other accessibility experts, including the AIM Center's Cynthia Curry, Andrew Halsley, Haley Orndorff, and Hannah Davidson, who are all doing research and really deeply entrenched in the accessibility space. So with their input, we developed a first evaluation tool that was targeted to STEM faculty who were seeking to evaluate and author OER. And then we piloted that tool, and essentially at the beginning, it was more of a checklist where they could look at a piece of OER and sort of run through a checklist to see if their OER was accessible. And we piloted the tool with STEM faculty that we recruited across the United States. And then based on what we found from that pilot, we turned what we learned into a full framework and an implementation guide. And I'll walk you through the guide in a minute, but just broadly, we aligned the framework with the core framework, which asks a set of questions. Can all students at least perceive the content? For example, is the typeface readable? Are there closed captions? The second question, the O, being operable. Are all students able to navigate and interact with the content? And in that space, we're asking questions like, is it screen readable? Can folks navigate through the content with a keyboard? And then the third question we're seeking to answer with the guidebook is, are all students able to understand the content? Is it written clearly? Are there clear descriptions and instructions included in the content? And then finally, the robust piece, are all students able to interact with the format, PDFs, et cetera, that are used to present the content? And then in order to address the STEM piece, we're asking, are students able to access and use content components that are relevant to STEM? For example, equations and formulas, data visualizations, data tables, simulations, and then maps and geographies. So we added the S to make it the PORS framework. And for each of the components of this framework and guidebook, we tried to define them, add a checklist, a list of best practices, and then tools that can be used. I'm going to jump out and show you the actual framework / guidebook. So it's licensed as a Creative Commons by license, which means, and it's a Google Doc, and anybody can take this, download it, adapt it to meet your specific context. And as I just mentioned, it's organized into the core framework. So folks can click through each element. There's 23 elements. And here's the nice STEM elements here: equations and formulas, data visualizations, data tables, simulations, and maps. Once you get into, I just want to show you a couple of the features of the guidebook. Once you get into, let's say you're on Perceivable and you want to start evaluating your resource, you've got the checklist here for that element. And then if you need to go deeper, you can click down to the definitions, considerations, and tools you can use to address that element. Then you can hop back to your checklist, move on to the second one. And then as we move through, we can keep clicking back down, keyboard navigation. It's got our checklist. I can go down to the definitions and tips to understand a little bit more about keyboard navigation, and then I can move back up to my checklist. So let's see, I wanted to show you a little bit more detail on the STEM. So for this piece of the framework, where we're asking if specific STEM elements are accessible, we have, for equations and formulas, We're asking if they're included as a markup language. And then if you don't understand what that is, of course, you can click down to the definition of tips where it explains what markup languages are, as well as tools for creating equations and formulas as the markup language. Then for data visualization, it walks you through a checklist on that, data tables, and then simulations and maps. And all of these tips, tools, and checklists were created by aggregating best practices and research in the field, as well as working with our accessibility experts. At the end of the document, you have a resource library which aggregates all of the tools that we point to in the document. I think that's all I wanted to show right now. And I'll flip back to our slides. Great, and give folks time for any questions. The link to the guidebook is at the bottom of this slide.
Thanks, Cynthia. I'm just going to add that if you join us after the break, we're going to go deeper into the application of the framework and guide to resources that may be relevant to you, some math resources, and have a discussion about the use of this framework in your work and OER in general, and some future work that we're thinking about and future challenges, and would love to hear from you all your thoughts on that.
Are there any questions right now before we take a break? All right, the second session will start at 3:55.
Great, thank you.